Hello and welcome to section 10.3, surface area of pyramids. Yesterday we learned how to calculate the surface area of cylinders. Today we're going to talk about pyramids. Our learning target is going to be to find the surface area of a pyramid. Our success criteria will be measured by our ability to use a net to find the surface area of a regular pyramid and our ability to find the lateral surface area of a regular pyramid. What's cool about pyramids is we've all seen like the traditional pyramid in Egypt, so to say, that has a square base, like this one here. But what's cool about pyramids is that the base of a pyramid can actually be any polygon. So we can have pyramid with triangular bases, pyramids with square bases, pyramids with hexagonal bases, octagonal bases, all kinds of bases. So that pyramids are kind of cool. So let's go ahead and get started with today's lesson. A regular pyramid is a pyramid whose base is a regular polygon. So regular polygons are triangles, squares, hexagons, pentagons, septagons, any of those, okay? The lateral faces are triangles. So that's what all pyramids have in common. All pyramids have lateral faces that are triangles, okay? They have a base that's some other polygon. Now that base can be a triangle too, but it can also be a square or an octagon or a hexagon. And all of the faces are triangles, okay? The height of each triangle is the slant height. Now keep in mind that when we're talking about triangles, when we're talking about a triangle, this piece right here is not the height of the triangle. This is the side length, but it is not the height. The height of the triangle is from the top to the peak, from the peak to the vertex. I'm saying the same thing. From the base to the vertex is the height, okay? That's my height. Now think about in a pyramid, this height is kind of slanted. So we call it the slant height because the faces of a pyramid come in together and they reach at the vertex like we see over here. They reach over here. So the height of the pyramid is actually called the slant height because it's kind of slanted. Okay. So now that we know the definition of a pyramid, let's look at surface area of a pyramid. So the surface area S of a pyramid is the sum of the area of the bases and the lateral faces, just like we've done before. We're going to find the area of the base, and then we're going to find the area of the lateral faces, and we're going to add them together, okay? So let's look at example 1. And in example 1, it wants us to find the surface area of the regular pyramid. Now here we have this pyramid, and it wants us to first draw a net. Okay, so I'm actually going to undo that circle because it's in my way. So the first thing we're going to do is we're going to draw a net. We have a square, and then this square has faces of it. So the square is our base, and then we've got 4 triangular faces, lateral faces, that make up the sides of our pyramid. Okay, the square has sides of 5 inches. And the triangular faces have slant heights of 8 inches. Okay, now that's important because what we're going to do first is we're going to find area of the base, which is going to be 5 times 5 because we're just finding the area of this square right here. So the area of our base is 25. And then we're going to find the area of one lateral face, okay? Now, area of lateral face. Remember, we're working with a triangle, so area of a triangle is equal to 1/2 base times height. So 1/2 base is 5. The base of this triangle right here is worth 5 times height, which is 8. Okay? 5 times 8 is 40. 40 divided by a half or times a half, however, half of 40 is 20. Okay, now that's the sum of that's not the sum, that's the area of one of our faces. Now, how many faces of this pyramid do we have? Well, if we count them, we have 1, 2, 3, 4. So the area of our lateral faces is not just 20, okay? It's 20 times 4, which is actually 80. Okay, and that's where when we look at the actual formula for finding the area of the base, for finding the surface area of the triangle, we have area of the base, which is 25, plus the sum of the area of the lateral faces, and there's 4 of them, so that's 20. 1, 2, 3, 4. So basically we have 80 plus 25, which gives us 105. Okay, so 105 inches squared, again, we're still talking about area. So that is the surface area of this regular pyramid, square pyramid. When I say regular pyramid, I mean square pyramid, okay? In math, we call a pyramid with a square base a regular pyramid, okay? So now I want you to do the try it right here. It says, what is the surface area of a square pyramid or a regular pyramid with base side lengths of 9 centimeters and a slant height of 7 centimeters? So I'm going to go ahead and erase some stuff while you're working this one out. And then by the time you get it worked out, I'll be done erasing and we can work this one out together. I'm not going to delete that one. So the first thing I'm going to do to work this one out is I'm going to go back and I'm going to draw the net just so I can see it. Okay, so we're going to come back up here. I'm going to finish erasing this stuff that I messed up here. We're going to draw the net of what this pyramid is going to look like. So it's a square pyramid, so I'm going to keep my square base. And then I'm going to draw my 4 lateral faces. And this one says that the base side length of 9 centimeters. So that means all 4 sides, because this is a square, so all 4 sides are 9 centimeters. And it says it has a slant height, which is right here, of 7 centimeters. Okay? So the first thing I'm going to do is find the area of the base. So I'm just going to write up here, surface area. No, not right there. There's not enough room right there. Maybe right here, surface area equals. So then here I'm going to find the area of the base. I'm going to call that AB, and that's going to be 9 times 9, which is 81. Okay, so that's this area of the base right here. I plugged that in. Now I need to find the area of a lateral face. So area of face is equal to 1/2 the base, which is 9, the height, which is 7. Okay. So I'm going to break out my calculator for this one because I know that 9 times 7 is 63, but then I have to do 63 times 1/2. So I'm going to use my calculator for that, and it's 31.5. Okay? Now, I am going to multiply that. I'm going to say plus 31.5, and I'm going to multiply that 31.5 times 4 because I have 1, 2, 3, 4 faces, okay? So I'm just going to plug that into my calculator. So I'm going to say second answer times 4 plus 81, and I get 207 centimeters squared for the area for the surface area of a regular pyramid with base lengths of 9 centimeters and a height of 7 centimeters. And that answer is correct. Okay, let's move on to example 2. Example 2 says to find the surface area of a triangular pyramid. Now, what's kind of cool about triangular pyramids is they come in different sizes. Sometimes the lateral faces and the base are the same size, and sometimes, like the one we're going to look at right here, they're actually a little bit different, okay? So the first thing we're going to do is we're going to notice that this is a triangular pyramid because it has a base that is a triangle. You can see that triangle right here, and then you can really see it in the net that they drew right there. So let's go ahead and we're going to come over here and we're going to draw our own net because I think it's cool. Whoa, sorry. Make you dizzy there for a minute. Okay, so we're going to draw a net. We have a base here, and then off of that base, you have, actually that's a crappy place to put the base, huh, Miss Cooey? right there. Delete. Get this back where we can see it good. Okay. Let's draw a raise down here. Fix it. There we go. Okay. And then we have, so it tells us that we have that our base, right, has sides of 10 meters, and then it tells us that it has a height right here of 8.7 meters. Okay, and that's important. You can see that pointing right there to that line. Okay, and then off of this we have our triangular faces, our lateral faces. And yes, I know that like one's a lot bigger than the others, but imagine they're all the same size, like this beautiful one that you see right here. Now this 10 meters is still the same, but we see that on this one, the slant height, actually let me erase this one because that one looks like crap. A little bit better. All right, we see that on this one, the slant height here is actually 14. We see that right there. So 14 meters. Okay? So what we're going to do first is the same thing. We're going to find the area of the base. Area of the base, which in this case, we're going to use the triangular formula for area, which is 1/2 the base, which is 10, times the height, which is 8.7. Okay? And again, I'm just going to plug it into my calculator. You can use Desmos. You can use whatever you have. A regular calculator will do this. You can use 0.5 for a half instead. And you get that the area of the base is 43.5 meters. Now we need to find the area of a lateral face. So area of face, okay? For this one, same thing. It's triangular, so we're going to do 1/2. The base on these ones is also 10. They share that same base, but the slant height on this one is 14. Okay? So this one is going to equal 70. And I know that because 14 times a half is 7. 7 times 10 is 70. Okay? And you can also see it right there. And now I'm going to add these all together, keeping in mind that the area of the face that I calculated is for one face, and there's actually 3 of them. So up here, I'm going to say surface area is equal to the area of the base, which is 43.5, plus the sum of the lateral surface of the lateral faces. Okay, so 70 plus 3. So I'm going to plug this into a calculator, even though I know the answers in the book right beside me and on the page. And I get 253.5. Okay, that was so backwards. 253.5 meters squared. And this is actually equals. I'm writing equals because I didn't round anything. I didn't estimate anything. I didn't use pi for anything. We're dealing with triangles now and squares and not circles. So your answer should be pretty exact. Okay? Okay. So now I want you to try it too. Find the surface area of the regular pyramid at the left. So I'm going to erase. It's weird that they called this a regular pyramid because I was always taught that regular pyramids are just squares. But maybe I'm wrong. Maybe I was taught wrong. Maybe a regular pyramid just means it's an unregular pyramid. I don't know what an unregular pyramid is. Interesting question. If somebody looks that up and tells me, I'll give you 5 extra credit points. All right. Find the surface area of the regular pyramid at the right. So again, we have a triangular base that we can draw. It has a base area of 6 and a slant height here of 5.2. Okay? And then this has its 3 faces coming off of it. Whoa, undo. That one was really bad. Undo. Leave my crappy triangles alone, Microsoft. Okay, So on this one, it has the same base of 6, but we have a slant height here of 10 feet. And these are all in feet. So let's start by finding the area of the base, which is going to be 1/2, times the base, which is 6, times the height, which is 5.2. I'm going to plug that into the calculator, 1/2. And just so you know, on the calculator, I am entering 1/2 as parentheses 1 divided by 2. So 1/2 times 6, which is actually 3, times 5.2 is going to give me 15.6. Okay, and then I'm going to calculate the area of the lateral face, of one lateral face, and I'm going to do 1/2 times the base of 6 times the slant height of 10, so we're going to get 30 there. There are 3 of them, keep that in mind. So our surface area here is going to be equal to 15.6 plus 30 times 3. So that is going to give us a total of 105.6 feet squared. Okay, 105.6 feet squared. I really would like to know if there was any questions. If there's any questions, let me know. All right, example 3, modeling real life, which means we're almost done. Hooray! It says the roof is shaped like a square pyramid. One bundle of shingles covers 25 square feet. How many bundles do you need to buy to cover the roof? Now let's think about this. If I am covering the roof, do I cover the base of the roof? Think about it for a minute. If I'm covering the roof in shingles, am I covering just the sides of the roof, or do I cover the top of the roof, which is actually the bottom of the ceiling too? Correct. I just cover the sides. I don't actually put anything on what would be the base. Okay? So we're going to look at this. It says, understand the problem. You're given the dimensions of a roof that is shaped like a square pyramid. You're asked to find the number of bundles of shingles you should buy to cover the roof if each bundle covers 25 feet. So what we're going to do is we're going to make a plan. We know that the base does not need shingles, so we're just going to find the sum of the area of the lateral faces, and then we're going to divide that by 25 to find out how many bundles we need to buy. Okay? So we see on our, so let's draw a net. Even though we don't need to calculate the base, let's draw a net just so we can kind of see this out nice and good. Okay, and we have a base here of 18 feet, and we have a slant height here of 15 feet. So all we need to do is calculate these 4 faces. We don't need to worry about the base, okay? So we're going to say area of the face is equal to 1/2 times the base, which is 18, times the slant height, which is 15, which is basically 9 times 15, which is going to be 135. Is my math right? Yeah, 135. Okay, so that's this right here, this 135 represents the area of like this one lateral face right here. Now I'm buying shingles for all 4 because I'm roofing the entire thing. So I need to calculate how much surface area I have on all 4 faces. So I'm going to have to do 135 plus 135 plus 135 plus 135, which is basically 4 groups of 135, which is 135 times 4. So 135 times 4 is 540. So the total surface area, the total lateral surface area, and we're calling it lateral because we're just finding the area of the lateral faces, is 540 feet squared. Now remember, each bundle of shingles that I buy covers 25 square feet. So what I'm going to do is I'm going to divide this by 25. When I divide it by 25, I get that I need to buy 21.6 bundles. Here's the problem. Can I buy 21 and 6/10 of a bundle? No, they come bundled up together, so I have to buy 22 bundles all together. Okay? All right, guys. We'll see you next time. Do good. Let me know if you have any questions.